Hello good people, this is Calculus 1 with MJ. Today we are going to talk about limits, an introduction to the limits. We're going to talk about how it all started. So without wasting much of our time, let's get straight into it. What is a limit? A limit is an idea that asks, as x gets closer and closer to a certain number, a, what value does the function f of x approach? Notice as x gets closer and closer to a, not necessarily when x is equal to a. Let's get into how it all started. The tangent problem. Let's talk about the tangent problem. Let's say you are given the following question. Find the equation of the tangent line to the parabola y equal to x squared at point P with coordinates 1 and 1. We need to find the tangent line's gradient or slope m first. But the problem is we only know one point of line at P, but we need 2 points to compute the slope. But observe, we can compute an approximate to m by choosing a nearby point T with coordinates x and x squared on the parabola and compute the gradient of the second line PT. For instance, for the point T with coordinates 1.5 and 2.25, we have m of line PT equal to y2 minus y1 all over x2 minus x1. That is 2.25 minus 1 all over 1.5 minus 1. That leads us to 1.25 all over 0.5, which is equal to 2.5. That's our gradient m of the second line PT. Now let's take x closer and closer to point P, that is closer and closer to 1, and calculate the gradient of line PT for each x value. Look, as we take x closer and closer to 1 from both sides, from the right and from the left. Behold, the closer and closer as x gets closer to 1, that is closer to point P, is the closer our MPT, the gradient of the line, is to 2. This suggests that the slope of the tangent line QPR should be m equal to 2. We say that the slope of the tangent line is the limit of the slopes of the second lines, and so this is expressed symbolically as the following. We read it as the limits of MPT as t gets closer and closer to P is equal to m, and the limit of x squared minus 1 all over x minus 1 as x gets closer to 1 is equal to 2. Now, assuming that the slope of the tangent line is indeed 2, we use the point slope form of the equation of a line to write the equation of the tangent line through 1, 1, our coordinates, as y minus 1 equals to 2 bracket of x minus 1 or y equal to 2x minus 1. That's it for the tangent problem. Next, we are going to talk about the velocity problem. Thanks for watching. Stay tuned.